Welcome to all. Today we see about the properties of proteins. Now, before classes, we saw about the different characters of proteins and the properties of proteins and classification of proteins and structures of protein, everything. So here, what are the basic physical properties of proteins? We studied about that. First, under this, the colloidal nature of protein. The protein molecules exist in the form of colloidal particle, 5 to 100 micrometer in dimension, are heavier than water and zinc. That means the colloidal in nature, somewhat the colloidal in nature, like the egg white, the structure, and that is heavier. Some are the micrometer in size. Some, if the heavier one, zinc in water. Next character, colloidal osmotic pressure. Colloidal proteins molecules exert osmotic pressure. So many proteins, especially albumin, globulin, are present in blood that exert the osmotic pressure. Osmotic pressure generated by plasma protein is often called the colloidal osmotic pressure or oncotic pressure of plasma. This pressure, which means the pressure that exert or uptake the water, accept the water and retain the water inside of blood capillaries. That is the duty of that pressure. That pressure is given by the protein molecules. That means the water molecule uptaken by the protein in and retained the water molecules inside of the blood capillaries by this protein. So this is one of the major properties of protein in plasma. The osmotic pressure of protein is proportional to its concentration. That means that is relative to its concentration that exert the pressure, but inversely proportional to its molecular weight. In it depended the osmotic pressure or oncotic pressure of protein is only related to concentration but not the molecular weight. In blood plasma, albumin contributes 75 to 80% of osmotic pressure. That represents no more than half the plasma protein because its molecular weight is lower. So the major concentration of blood plasma is occupied by albumin protein. That means the 75 to 80% of oncotic pressure is exerted by the albumin. Oncotic pressure exerted by protein is clinically important in maintaining blood volume. It is very important to maintain the blood volume. Next, we see about the molecular weight. The macromolecule, the proteins are already we saw about that, the macromolecule. So have high molecular weight with wide variations. Example, albumin have 69,000 and gamma globulin and 1,60,000. So the albumin is lowest molecular weight protein. Next, solubility. In general, the globular proteins such as albumin has highly solubility than elongated fibrous proteins. Moreover, smaller molecules are more soluble than larger molecules. Shape of the protein, we consider the shape of proteins. Scleroprotein like keratin and collagen are in the form of fibers, while soluble protein tend to be the round shape and are called globular proteins. Example, albumin, globulin. And next, hydration of proteins, which means when brought into contact with water, the protein contact with water absorb water. That protein absorb the water and swell up. Example, the dal used in cooking that uptake the water. So like the sponge. The polar group like because Why it has uptaken the water or absorbed the water? Because it have the functional groups COOH and NH2 and hydroxyl. That means carboxyl and amino group and hydroxyl group of protein. That is the function. These are the functional groups or polar groups. Polar groups means the water attracting, water reacting. So protein bind to the molecule of water by hydrogen bond to hold a considerable amount of water. So these functional groups having hydrogen contact with the water molecule again produced a bond between them, and that produced a that retain the water in higher amount. Thus a relatively immobile shell-like layer of water called. So this uptaken layer of water is called a solvation layer or water envelope. So outermost layer we saw in a dal mixed with water, that is cooked dal with water. The outside is immobilized by water. So that layer, outer water layer, is called solvation layer or water envelope, is held around each protein particle in an aqueous medium. Next property, amphoteric nature and the isoelectric pH of the protein. This character already we saw in properties of amino acid. So either isoelectric pH of amino acid has been described in before classes, but one end of the protein molecule has free amino group, that means the base group, and another one is COOH group, that means the acid group. In acidic solution, the amino group accept H plus and present as ammonia and produce ammonia. Therefore, protein in acid solution will be positively charged. In alkaline pH, the COOH group donate H plus ion and are present as COO minus. So H plus is released in here. So alkaline solution are negatively charged. So the both properties in one substance, that is known as ampholytes. So next one is in one side that is act donor and another side that act as the acceptor. Next we see about isoelectric pH of the protein. For every protein in solution, there is particular pH at which the number of anion formed is exactly equal to the number of cations. Simply, the equal number of anion and the equal number of anion and cations are produced a protein by a particular pH in a particular pH. That pH is called isoelectric pH or shortly PI of the protein. So in this state, the ions are called switcher ion. That means the equal number of anion and the cations are called as switcher ion. At isoelectric pH, the protein molecule do not migrate in any electric field. Solubility, buffering capacity and viscosity will be minimum and precipitability will be maximum. So in this state, the solubility is high and solubility is low, buffering capacity is low, and viscosity, and that means the density is low, but the high precipitation rate is high. The PI, that means the isoelectric pH of some proteins, are given below. Pepsin, one of the enzyme that involved in protein digestion, that have the pH 1.1 acidic pH. Next, casein 4.6. These in this isoelectric pH only, that protein are active and produce the precipitability. Then albumin have 4.7, globulin has 6.4 pHs. All pH values above or below the isoelectric pH, they carry net negative or positive charge and migrate to anode or cathode, where not, that is, moved towards other side, so that is static in nature. Anode and cathode, that is not moved or migrated in any other direction, so that state is known as isoelectric pH. Next we see about the precipitation of protein. The stability of protein in solution depends on the charge and hydration of protein molecule. The factors which neutralize the charge or remove water of hydration will cause precipitation of protein. So many factors can precipitate the proteins for estimation used for the estimation and diagnostic purposes. So these are under follows. First one, salting out method. In this, so many salters are used to precipitating the protein. Next, isoelectric pH. A particular pH is applied to the protein mixture, so the proteins are precipitated. Then heavy metals are used for this technique, and the organic solvent, some of the organic solvent applied in the protein, that protein is precipitated. Then salt first, we see about the salting out method. Neutral salts such as ammonium sulfate, sodium sulfate are actors, the precipitate the protein. Next, mineral ions attract water molecules and remove the shell of hydration, so the protein molecules are precipitated. Next, method is precipitation at isoelectric pH. All protein least soluble at their isoelectric pH and can be precipitated. Heavy metals used like tungstate, trichloroacetate, pictrate, zinc. So these are the heavy metal used for the protein precipitation. Next, precipitation by organic solvent. Some of the organic solvent like alcohol, dehydrates and D-alcohols, that which are dehydrates the protein mixture and precipitate the protein.